Tarek, are you here? Nope.
Wrong way. MPLS.
Let's see.
You can of course fix it easily, but
Are you able to start the modeling? I'm looking to get the new blue sheets. Just go.
I have to reboot my laptop, so it takes a while.
Yeah, if you can show the agenda. Maybe so switch over to the VGA. Yeah. Give me 1 minute to try and take it.
Okay, finally we go. Good morning. It's the second session of the MPLS sessions. First session was on Tuesday. Note well, please note that every statement you make, either in written or verbal form, is seen as a contribution. Minute takers, we have a minute taker. Do we have a JavaScript somewhere? No. So who wants to be the JavaScript?
Don't spend time on it. Just do that.
Okay, no one. Okay.
Which one?
Yeah.
We had a screw up on the blue sheets. Stephanie will be bringing them in and we start circulating them as soon as they come.
It's correct.
Yeah, so all information are of course on the website, and we will start today with the remaining presentations for the Friday. I think first one is Kireti. I need another 5 seconds.
Okay. Hey, there we are. Blue sheets.
Great. Quiet. Yeah. Oh, it's the wrong presentation, sorry. So.
Okay. So this is an update on the RMR document. There are a couple of things as we're having discussions within Juniper and also with some of our customers on what we should do with RMR and how applicable is it to their networks. We came up with two things that are really important. The first is egress node protection. It's actually very similar to what happens with PE protection for VPNs, what in BGP you call pick edge, or LDP protection. So a number of things, or pseudo-wire protection. But in RMR, one of the things is we want to make things very simple to configure. So the question is not just how to do it, because we have lots of techniques, but how to do it in a way that's very easy to configure. So the problem is illustrated here. You have a ring, that's the thing in blue. You have these two purple dots or purple devices, which is the ring's connectivity into the bigger network. And if I have a node A talking to a node B outside the network, it's exiting from the purple thing called X. If a link fails, RMR will give you protection going back to X, different path, and then you can continue. But if the node X itself fails, what do you do? And so you really want to go to the other node and then go into the bigger network. And so the question is, how do you do this? And like I said, we have techniques for this. The other question is how to make this really simple to configure, how much of this can be done automatically. And this is all part of trying to make these rings as close to self-configuring and self-managing as possible. So we have some ideas, and the next version of the draft will contain some of those ideas. We invite you guys to comment on the list. If you have thoughts about this, if you have comments on the suggestions that will come out in the next version, and if you can see other ways of doing this. The other thing that's really interesting is this thing called a half ring, which is either a ring that's incomplete. For example, there's your ring, kind of, sort of, just the dark black part, and either they're connected via a core node or a node deeper in the network, or they are connected directly, but the ring is in level 1 and that connecting link is in level 2, or the ring is non-backbone and the connecting link is backbone. So we don't want to leak the ring announcements from the non-backbone to the backbone, so it looks like an unconnected ring. And so the question is, how do you actually complete this ring, and how do you get the protection you want? Because if one of the nodes, one of the links in the ring fails, the purple dot can't talk to a lot of things, and so it's not really a ring, but it's kind of a ring. The thing is, it's quite a common or a reasonably enough common topology that it's useful to have an answer to this. So, if you think of it as just what's happening in the non-backbone area, that's what you get. So you can call this a horseshoe, as some people do. You can call it a half ring. Greg.
Yes, actually,
Greg, I'm in line. Are you going to ask a question on the slide?
no, it's just a comment on the slide because it's a well-known problem in IGP. You have your area split and you use it, at least in OSPF, as a virtual links to repair.
Yeah. The thing is, it's not only a control plane thing, it's also a data plane thing.
Okay, are you done?
I have one more slide, but I'm not.
Yeah, okay, so I want to ask you a question, and this is kind of pretty pregnant. Do you realize that this is a working group document?
Do I realize?
Yeah.
Yeah, I think so.
So you come back and say, we within Juniper has discussed this with our customers. There has been no discussion whatsoever on the mailing list. So why don't you treat it as a working group list and take the discussion to the list?
Yeah, I will. The thing that
You haven't done so in 2015.
So the idea
We
of
had
offering
zero discussion, with the exception for one very good review a year and a half ago.
right.
That's everything that actually happened on the list, except for one mail asking for comments, and the announcement mails. So I don't find that you really treat this as a working group. You treat it as an individual draft.
That's not true. The half ring was a discussion that we had internally. Should we bring this to the working group? Should we actually consider this as a problem for RMR, which is a ring technology? This is not a ring.
So if you have discussion with your customers,
Yeah.
and there is no discussion on the mailing list, it is still treated as a working group document.
You're not getting my point. It's not whether it should be in this.
I'm actually not talking about the half ring. I'm talking about the document as such.
Okay. I mean, we didn't know whether this is relevant to rings. And when we talk to customers and they say, we would like to deploy this technology, but if you don't solve the half ring problem, this is not interesting to us. At that point, we have to have a discussion. Do we not consider half rings as part of RMR technology, or do we do that? Once we do, we make the decision, we want to try to do this, we'll bring it to the list, which is why I'm talking about it here.
So how long ago did this show up? Last week?
Not last week.
Yeah, okay, so you had time to actually bring it to the list before the meeting.
I did it in the update. So if you look at the update, it's discussed there. It's in the document. But for me, the bigger question is the working group interested in this problem? I can bring it to the list. I can talk about it here. I mean, what order do you want me to do this in? It is in the draft, and I'm talking about it here.
So the thing is that the problem I have is that I see no discussion on this. I see no interest whatsoever on the mailing list.
Okay. I mean, I'm not sure what.
So what you need to do is actually go back.
Yeah.
And actually start the discussion on the mailing list of all the topics that you bring up in the meetings.
Right. So far, the topics that we've had discussions on, we have completed those. So, for example, how to signal this in RSVP. There was discussion with George, and we brought it to the mailing list and we put it in the document. This discussion was something that internally we were not sure we should do this in RMR.
So when did that discussion happen on the mailing list? Because I can't find it.
The RSVP one?
Before it became a working group document?
No, the RSVP one was when we did the RSVP.
Is this a productive use of our time?
Yeah.
Okay, sorry. Please go ahead and finish up quickly.
Sure. Yeah, because you just wasted all my time. So the thing that we want to say here is half rings are common enough that even though they're not a ring and even though they have trouble, Greg suggested we can do the virtual links. We've thought about that, but you also need the physical connection so that you can do the protection in the data plane. Should that be is that an interesting topic for RMR as a technology? And our answer is yes, because there are enough people who want a solution to this. And that's why I say that I want to bring this to the list and I want to propose solutions. And if either people have better solutions or they like the solution, or they think it shouldn't be solved in RMR because it isn't a ring, that's for us to decide. So basically, I think these are both good problems to think about. In the context of RMR, that's because it's a working document. The group has to decide whether we should solve these two problems. Like I said, the first one is not hard to solve. It's just how to make it self-configuring. The second one is a half ring a close enough variant to a ring that we want to solve the problem in the context of RMR, or we could do it in different contexts. And so we'd like to bring those 2 points to the list, have people have a discussion on that. At that point, I think we're done with all the technical updates to this document. I ran into AC yesterday. He said, before you progress this, bring it to ISIS and OSPF, just because there are encodings there. And so at that point, once we've settled these 2 points, we'd like to propose that we prepare the draft for working group last call and then move it forward. Questions, comments?
Okay. Next presenter. Is Greg? Okay. Greg. We are a bit short on time.
Okay, yeah. Sure.
Okay, so for those who are watching this as a second series this week, we had a discussion on BFD directed, and this draft is application of idea of controlling the reverse path of BFD session to the segment routing. Again, the problem with the BFD as a method of monitoring continuity of unidirectional paths is the return path might create false negative. So it could be because their network that used for reverse direction is less stable than the forward direction. So then that's why ability to control reverse path might be beneficial. So the proposal is to use reverse path BFD reverse path TLV in conjunction with the BFD discriminator TLV in LSP ping to change the reverse path used by BFD session identified by BFD discriminator. Spring LSP ping for Spring networks introduces 3 new sub-TLVs, and they can be used to specify the reverse path. But here isn't some interesting idea for the working group to discuss and for everybody to discuss. Unfortunately, Spring group doesn't meet this week, and I'll bring it to their mailing list as well. In RT types data model, LSP label stack is characterized as a list of labels. And we have started discussion because they use explicit index. But even if you use explicit index, you still can do exact reordering based on indices. So why not use explicit label stack and pass it to the far end remote BFD node to use as a reverse path for the over segment routing MPLS, with the MPLS domain. So that's one of the proposals in this document. So,
Comments? You want comments?
if there are any comments to this, I appreciate it. If not, we'll continue discussion on the list.
Okay. You want to next?
Yes. Okay. So RFC 5880 introduced several modes for BFD. In RFC 5884 for MPLS LSP, only use of asynchronous mode is defined for MPLS LSP. And that's been for, since we adopted RFC 5884. But there is a very interesting, with interesting properties, mode, demand mode. And demand mode can be asymmetric. So one node of 2 can be in demand mode, whilst another node is an asynchronous mode. And that gives us very interesting properties, because in demand mode, the node ceases to send periodic BFD control messages. And that node can be put in demand mode and taken out of demand mode by its remote peer. So again, that's a very familiar picture for you. Okay, so we have MPLS LSP from node A to B, and then over some other network path, disjoint is for the reverse session. So the idea, the proposal here is to use how we can use demand mode for MPLS network. And actually, RFC 5880 suggests that one of the use could be if we have multiple sessions between the same pair of nodes, and we want to minimize number of reverse sessions. And we do have a codification of RFC 5884, which defines that because you can have ECMP domain between LSP, so multiple LSPs between two endpoints, and you want to actually, it's suggested that you monitor all of the LSPs, so you will have multiple BFD sessions over MPLS LSPs between the same two nodes for the same FAC, but you don't want to have each of these sessions to have a reverse path. So the proposal here is that the far end node, node A, bootstraps the session with a BFD discriminator, and node B sends BFD control packet with its BFD discriminator, and they start forming the session in asynchronous mode. But once they reach up state, node A can tell node B to go in demand mode. So node B has to stop sending periodic messages. At the same time, node A can verify that node B is alive by initiating pulse sequence. And then node B will have to respond with the F bit. There might be some extensions to that what can be done, that if we want to, node B to monitor and report on continuity loss of messages from node A, so node B can send in diag field loss of control. It's effectively, we call it RDI, I think that we referred it in MPLS-TP document. RDI bit set with a poll sequence. So that's basically the mechanism. Once node A receives their RDI indication from node B, it identifies the session as down, goes to the slow sequence, but maintains their discriminators. So basically it will be node A starts sending very sparsely, usually once a second, BFD control packets, but with all BFD discriminators. So thus, when the when LSP restored, it doesn't need to have a new LSP ping bootstrap. And it does it in asynchronous mode. Once the session goes up, again, node A may instruct node B to go in demand mode, and we have effectively the same thing. I must note that this proposal does have IPR, and the legal team is working.
Okay. There is an IPR disclosure on the
There is no formal disclosure because I asked the legal team to work because I know that what would terms.
Sorry, if you wonder what I asked if there was an IPR disclosure, but Greg is responding that there is not, and that there will be.
Yes, there will be, and it will be what's called covenant. Okay, so that explains how it fails and how it restores. And I appreciate comments. And per agreement with the BFD working group, I'll bring it to discussion to the working group. But again, I would appreciate the suggestion whether it's applicable more in BFD group, because it somewhat changes or in updates 5884 with the new mode.
Can you send an email on that?
Huh?
Send the email on that.
Okay.
Any questions for Greg here? Okay, next one.
Sorry, this is Chamber. Okay, so BFD working group is now completing its work on BFD for multipoint networks, or we can call it BFD for point-to-multipoint and broadcast. So this is start on investigating applicability of BFD for multipoint networks to point-to-multipoint MPLS LSPs. Just to give a digest of how BFD works in the multipoint networks, it uses demand mode. There is no three-way handshake. Obviously, there is no discriminator allocated by the leaves. All discriminator comes from the root. So thus, it complicates demultiplexing sessions by the leaf. Normally in BFD, per BFD RFC 5880, the demultiplexing is done by locally allocated UR identifier. So basically, the value that comes to the node in your discriminator field, that would be locally unique identifier discriminator, because such is missing, is absent in point-to-multipoint version. There needs to be some other fields. So what multipoint BFD suggests that it's done by source IP address, discriminator that is assigned by their root, and identity of their interface it was received. So that sets some interesting restrictions on what we can do with their point-to-multipoint MPLS. Yes, and actually there is some change in, obviously, state machine, because their session is viewed as up all the time. So the one possibility is use IP UDP encapsulation, and then as described in RFC 5884, so for IPv4 we use IP address destination from 127/8 range, or for IPv6, so another Martian. So we use a destination UDP port assigned for multipoint BFD, and the source UDP port should be selected from dynamic port range. Is it possible to use non-IP encapsulation? Because frankly, with a very small BFD control packet size, waste, especially IPv6, IP UDP header for IPv6 is kind of waste. It's possible, but we need to remember that there is a requirement for multipoint, for BFD for multipoint networks to have association, to be able to associate each BFD control packet with the source IP address. So the proposal here is to use gash encapsulation with a CV channel, possibly reuse existing channel, and then use new source map ID IP address TLV. That's basically the channel already been allocated for MPLS-TP. It uses, it has a registry of map ID TLVs, but it doesn't have IP address TLV as a source map ID. So, and bootstrapping might be done either using LSP ping or multicast VPN fast upstream failover has very nice proposal to use BGP BFD attribute to inform the leaf that is a member of the particular multipoint BFD session. I think that there needs to be done some enhancement to BGP, or it's look at how this BGP BFD attribute can be used to remove BFD session. So just basically probably do withdrawal. Again, comments welcome. And I think that this work probably more belongs in MPLS because it's applicability of BFD without any changes to BFD specification for MPLS point to multipoint OSP.
Okay. Any questions for Greg? Okay, I think not. Thank you very much. Next presentation, Tarek. He's still a little bit short in time, right? 1 or 2 minutes short.
Okay, hi everyone. This is a quick update on 2 drafts that are defining the MPLS Yang model and the MPLS static Yang model. I'll go over the updates, the open issues, and the next steps. In terms of changes, we've migrated the ability to configure an MPLS label stack from a leaf list to a list. This was needed because we can have the same label appearing in the list multiple times, so we have to have a distinguisher in there in the list. We did meet with authors of RIB extended model. We think this model has some intersection with the MPLS RIB model, and we discussed with them moving some of the things that we defined in MPLS because they're generic and applicable to IP world, and they agreed to do so. So I'll go over the agreed upon changes. The first item we updated is the MPLS label stack, as I mentioned, and we introduced this index. The index, so there was a discussion on should we use the index as an offset in the label stack. We're talking about an ingress or a node pushing a number of labels. And we are listing those labels indexed by a number. So should this number be equivalent to the offset in the label stack? So Yang defines two modes of ordering a list, either user ordered or system ordered. User ordered, basically the way they appear in configuration is the way that the labels will be slapped on the packet or pushed. So the index is not of relevance then, but the order appearing in configuration is. If we go with this approach, then we can always insert after or before an item, or even remove after and before. If we use a system ordered list, then the system can choose any ordering that they see fit. The order of configuring the labels is not of importance. They can sort using the index. Let's say, for example, the index is not consecutive or contiguous. They can sort it by index and generate an offset off of that and produce the label stack. So obviously, every time we add a label in that list, the backend has to do some sorting to produce the final set of labels to either push or update on the packet. So these are two modes that we tried to discuss. Some are favorable of using the index as an offset. I think I spoke about that. The issue with using the index as an offset is if I configure an index number 2, there must be a check that a previous label at index 1 is existent, because you can't slap an offset number 2 without having a label before that. So there is some additional verification needs to be done if we do that. So this label stack is relevant in configuration at configuration time, as well as in the state model in the MPLS red model. So in the top on the bottom of the tree there. So the MPLS routing types Yang model has defined an MPLS label stack. They have defined an encoding which exposes the TTL, the traffic control, and the label value. So basically, they expose the whole label when trying to configure a label stack. So we wanted to have a discussion on should we allow specifying TTL for non-top label for every label in the stack that we're trying to push? Should we allow specifying traffic control or traffic class per label? Greg, do you want to ask your question now?
Yes.
Okay, go ahead.
Actually, there will be I think that is related to
the previous
Stuart. One? Yes, previous. Because, I started discussion of in the corridor with Zhufeng, synonymous flow labels. So they will affect how we present it, because for the same index, we might have multiple labels. And we want to configure them, and then how they will be reported if we have synonymous flow labels.
Right.
Again, that's something that probably we'll need to discuss it.
Right.
We started thinking about it, but nothing came up very, like, in an instant. So that's some problem to think about.
Right. Thank you. Yes. So back to the label encoding of entries in the list. Currently we are showing the label values in the label stack, and on the previous slide here, the list is composed of label value entries only. No TTL or traffic class is allowed to be added, but the routing type, as I mentioned, is defining this grouping that exposes label value, TTL, and traffic class. Now, if we allow traffic class to be configured on anything beyond the top label, then there is some intersection with RCs defined for the short pipe, the pipe, and the uniform pipe model for the TTL as well as the traffic class. This is applicable at disposition time as well as imposition time. I tried to go over that. I didn't see anything alarming, but if somebody thinks that specifying TTL in the label stack could cause routing loops, for example, please highlight that.
Tarek, I don't think it can cause a loop, but I think it could cause a problem when it's looping.
When?
Yeah, I think what I'm saying is that I don't see that configuring TTLs in the label stack will cause any loops. But if you actually have a loop, you might have real problems.
Right. Yeah. So if the packet loops back, we are not decrementing the TTL possibly at disposition time. Is that the behavior that we want? So this is what we want to highlight.
Lou Berger, question. Clarifying question.
Yeah.
Is TC included or excluded right now?
Right now in the models that the static model at configuration time, we're not allowing TC.
What if you're like trying to configure an SR stack?
Right.
Wouldn't you want to have TC there?
Probably for every segment you want to allow specifying different or same traffic class.
Yeah.
So it's favorable. Maybe it's applicable for TC, but do we want to allow it for TTL as well? So TC maybe is
TTL I have less of an opinion on, but if TC is not, I think you said TC is not there, correct?
Currently it's not in our model.
Yeah, I'm suggesting that it might be a good idea to include it.
Yeah, it's a good idea. I agree. Should we then update the grouping defined in routing types, or have a different grouping without the TTL there? That's the question I will ask to the routing group Yang modelers.
Okay, okay, Greg Mirsky, ZT. I'm a little bit not sure I see the problem that including TTL in a defined stack will cause a problem if there is a loop.
Right. At least in the uniform model, you're supposed to keep the top label TTL all the way through, right? When you dispose, you basically, the top one keeps decrementing.
Okay, might be better to take to the list.
I did leave a reference for that RFC that talks about the pipe, uniform pipe model. Yeah. There were a couple of attributes in the route that we introduced as MPLS attributes, but they're applicable to IP routes as well. We did take this discussion with the extended RIB draft authors, and we are following up with them on this, and we will update our model to comply with that. There is an open issue to migrate to NMDA. I think the recommendation is to go ahead with that, and we will do that. So the next steps to address the open issues that I presented, and we request further review and comments from the working group. Thank you.
Any further questions? Okay, so next is Adrian. Adrian Farrell.
Jump right in. Can I do 3 shows of hands? Who was
in the RTG, no, do the other way around. Who was not in the RTG-WG meeting earlier? Good, that's no hands went up. Who was not in the first MPLS session where draft shoe unified thingy? So that's about, oh, that's about 10 people. Okay, so Stuart had some of this material in his slides in RTG-WG, and there's an overlap with the draft shoe that was in the first session. So this is the last slot I'm offering. Third show of hands, who would like me to not present this? That's okay. So there's somebody from Juniper and somebody from Juniper's customer. Oh, okay. I will go through it fairly promptly. Our objectives then in looking at this work is to provide a way to tunnel MPLS-SR over an IP network. So to connect two SR networks, for example, data centers or enterprises or whatever. Second objective, to try to provide a unified approach to segment routing with the option then of using the same SID stack in all SR networks, which simplifies the processing you have to do in protocols, but also in silicon. And to provide an option for a phased deployment of segment routing, so that not every node in your network has to be upgraded at the same time, but you can start to roll out SR. We do want to be able to coexist and have MPLS-SR and SRv6 coexist. We think that there are different solutions for different environments and different needs. So this is not a proposal to kill SRv6. This is a proposal to add another string to the bow. So the overview is really RFC 7510. Those of you with long memories may recall this took us quite a long time to get through transport area, even though this working group was quite cheerful about it, but we're there, and our major proposal is simply to reuse that. Nothing smart about this. Encapsulate an MPLS SID stack in UDP in IPv6, address to the next SR capable node along the way, which in the tunnel is just the end of the tunnel, or it may be sort of hop by hop, and use the UDP destination port to say there's MPLS below. Is that the specific port?
There is already a port allocated, UDP destination port already allocated for the payload is MPLS. That's what 7510 does. So in a little more detail, you see from the bottom upwards, the payload is entirely unchanged. You just pick up the payload and drop it underneath an MPLS SID stack, just like if you were doing MPLS-SR. And you drop that itself into a UDP header, just like you were doing 7510. And then on top of that, you put the IP header to get you across the network. You set the source to the sending SR capable node. In other words, the person doing this encapsulation. You set the destination to the next SR capable node that is going to process the SID stack. And you set the next protocol to UDP, of course. So SIDs get advertised. There is no change to the way the SIDs are advertised and configured, et cetera, et cetera, et cetera. This is just, the SR piece is just SR. And we believe that all SID types can be supported in this way, and there's nothing new. So I have 3 slides, say who does what in the network. The source builds the SR stack, just like it was an SR node. It encapsulates, setting the fields as I just described, in UDP and then in IP.
The little wrinkle is that to set the destination address, you've got to look at the top SID in the stack and say, where am I trying to get to, and map that. But you can take that mapping out of the SID advertisement. And then once you've encapsulated, you look up and send. So it looks really like 7510 with how do I decide what the end of my tunnel is, being I look up a SID. So if you're a transit and you're not SR processing, it's pretty important that we can get these packets through non-SR nodes, and that's fine because they're IP packets and they just go. No special processing at all. And ECMP, where it exists, you get using the entropy in the source port, just like 7510. TTL behaves as normal. It's an IP packet. If you're a transit SR node, well, there are two things. If it's addressed to you, you need to work on it. If it's not addressed to you and you're SR capable, you don't touch the packet. It's just an IP packet being routed through. So if it is addressed to you, you look at the packet, you go, oh, it's UDP, oh, it's MPLS in UDP. Now I look at the SR stack that's in there, I get the next hop, and now from now on I behave just like I did at the ingress. I look up the SID to find the IP address for the next hop, and I encapsulate again, look it up and send. So a transit is effectively doing the same work as an ingress. So two use case pictures. Yeah, just checking the colors came out okay. The top use case is where this work sort of started, which is tunneling between two domains, the way 7510 is talking about it. And your SID stack's quite simple because it's just the target border router and you're tunneling. The more entertaining case is where you've got an IP network with three types of nodes: legacy IP routers that don't do SR, SR-capable routers that you're not actually addressing in the SID stack, and SR-capable routers that you are addressing. And so you're essentially doing big hops across the network, hopping over the legacy routers by just routing through them, hopping over the SR-capable routers you don't care about, and then actually doing SR processing at what are the red nodes in this map. And, well, this is a 0-0 draft, so it's got some bits in it that are wrong, and people have been helpfully pointing those out to us in subtle or not so subtle ways this week. So we know we need to polish. There is the issue of the overlap with draft show, and the authors had lunch. The authors of both teams had lunch earlier in the week and agreed a way to move forward so that there's only one document for everyone to look at, which I think will be helpful. We think that actually this work is pretty obvious. I think one of the comments we got offline was, yeah, this is just virtual interfaces and you're sending packets. And yes, that is exactly what it is, with just a little bit of help to say, when you send it out the virtual interface, how do you know which virtual interface to send it to? We think it's in Charter, but we also think it needs some more polish and discussion before we make the traditional quest. It would have been nice to end the last presentation of the last working group with, can we ask for adoption? But I'm not going to do that.
Bruno de Crane, Spring co-chair. I'd like to present that work in Spring because I think it would be interesting for Spring. I would personally think it would be more in scope for Spring because the way I see it is a third data plane for Spring. And from a technical point, I'd like the OEM part to be enhanced. I'm not sure how I see end-to-end OEM, specifically during transit. The IP source is a transit node, I'm not sure to see how package comes back to the original source, but it's a detail, but I'd like to see more in OAM.
Good. So I think Stuart's got up to answer the OAM point, but I'll just answer the other things. Yes, of course, we'll talk to Spring about this. We weren't on the agenda for the Spring meeting this time round for
obvious reasons.
Obvious reasons. As to the fight about where it ends up being adopted and worked on, yeah, whatever. I mean, we're not actually changing the Spring data plane. We're just doing an MPLS encapsulation. But I'm not religious about Spring.
It's not about a fight. It's to be consistent and to be sure that anything we do with regular Spring MPLS can also be done with that proposal.
Yeah.
Or anything we can do with SRv6 could also be done with that proposal. And to be sure it's all in sync.
Yeah, I think actually, I'd be happy if across the area we were consolidating the Spring work back into Spring. There's been a history which we don't need to go into, but at the moment, if you look at where the Spring work is, less than half of it is in Spring.
Yes, I agree with you. But protocol extensions are outside of Spring, so
Bruno,
that's one reason.
How about this? We take it off list, we discuss it among the authors and chairs of both working group, and we decide exactly what to do, or probably involve ADs at least at one stage.
Absolutely.
And to OAM, we need to work it all through, but I'm hoping we can inherit a whole bunch of existing MPLS OAM to make this work. MPLS OAM has got the concept of returning to an answer to an IP address.
I'm not saying it cannot be done. I'm asking for more details.
Yeah, well, we need to do the work, right?
Okay, thank you, Marian. That was our last presentation. MPLS meetings in Prague this time is concluded. See you all in Singapore, I hope. One thing. Where are the blue sheets? Bring them up to the front and sign if you haven't done it.